Hey guys, today we're looking at a couple different topics, experimental and theoretical probability. All right, so a couple things to write down. So first of all, we're going to talk about experimental probability. All right, and experimental probability, of course, is going to be what happens when you figure out your results based on something that happened. All right, so we say it's based on repeated trials of an experiment. So if I go through and I do something, 50 times, right? What was the outcome over that 50 times? All right. Maybe I flipped a coin and it was heads, 12 times out of 50. That would be an example of my experimental probability. Okay. And here you're going to see a little bit more about what I talked about. All right. Here's an example. Let's say I flipped a coin 50 times and it was heads 20. What is the experimental probability of getting a heads? All right, so based on my experiment, what I just did when I flipped my coin 50 times, right, I got 20 heads in 50 total rolls. All right, if I reduce this, I could get 2/5. All right, as a decimal, I could write it as 0.04. All right, or as a percentage, right, 40%. Okay. So those could be some different ways that I could write my answer, all right? Any of these would be acceptable, okay? Now, we talked about experimental probability, which measures exactly what did happen, right? Measures what did happen. Now, a lot of times when we come up with something, we talk about theoretical probability, okay? And theoretical probability is what should happen in an experiment. Okay, so if I flip a coin twice, how many times should I get heads, right? It should happen once, right? Because we all know we got a 50% chance of getting heads when we flip a coin. Okay, and so here again you can see your equation for figuring out the probability of a theoretical event, right? Again, it's your favorable outcomes divided by the possible outcomes, or I could even maybe say, the total number of outcomes, right? How many times did I roll my dice or flip my coin or pick a marble out of a bag or whatever it happens to be? All right, now, what do we know about this? How would our experimental and theoretical probabilities compare, right? So when I explained my heads experiment, I got 40% heads. But theoretically, I should be 50%, right? So they were different. Now, will they ever be the same? And that's a good question. All right. And the idea is, guys, is that the more times we do an experiment, the closer we should end up getting to our theoretical probability. All right. So, yeah, I could flip a coin 5 times and I could get heads all 5 of those. So in my experiment where I flipped 5 times and 5 heads, that's 100% true. But now if I go from flipping 5 times to 10 or to 20 or to 100 or 1,000 or 1,000,000 times, is that going to continue? And of course not, right? So the idea is that the more times we conduct an experiment, the closer it is going to end up being to the theoretical probability. And this is actually something called the law of large numbers, but that's another topic for another day. All right. So again, the idea of theoretical probability, right? If I flip a coin 50 times, all right, okay, how many times should it be heads, right? Well, it should be 25, right? And this is why, okay? And this one I just wrote our answers down because it's pretty intuitive, right? But the idea is, all right, I know if I have a coin, I have 2 options, right? I have heads or tails. I have a 1 in 2 chance of getting the heads or a 1 in 2 chance of getting tails. All right? So now if I'm going to do this 50 times, I'm going to take my probability, right? And then I multiply that by how many times I'm doing my experiment. And half of 50 is 25. Right? So coming up with your theoretical probability, right? We set it up based on our number of outcomes, all right? And then we can multiply to get our answer. All right. So how about this here? If I roll a 6-sided dice, all right, what is the probability that I roll a 2? Okay. So what can I do here? All right, if I have a dice, I know that all of my options are 1, 2, 3, 4, 5, and 6. Those are the only sides that are on a six-sided dice. All right, so how many total things do I have? I have 6. Right? Now, how many of these are a 2? There's only one way to get a 2. So my theoretical probability of rolling a 2 would be 1/6. All right. Now, same type of question. We're rolling a six-sided dice, so we know our possibilities are 1, 2, 3, 4, 5, and 6. All right. So again, we still have 6 possible outcomes, but now it's asking us to find the probability that we roll something greater than a 2. All right. Well, which of our options are greater than 2? 3, 4, 5, and 6 would all be greater than 2. So I have 1, 2, 3, 4 ways this is true. Okay, so 4 and 6, or I should always reduce my fractions, would be 2/3. All right, same type of problem here. Okay, but now we got a wheel. So the probability of winning a prize on the wheel is 1/6. The wheel has 18 sections. How many sections have a winning prize? All right. So if I have a 1 in 6 chance, okay, a 1 in 6 chance, and there's 18 total sections, what I can do then is I could multiply these together. All right. How many sections have a winning prize? Okay. And if I do this, right, 18 I could rewrite as 18 over 1. So this would be 18 over 6, which is 3. So I have 3 sections that have a winning prize. So that's how we could set this up in terms of a formula. But guys, we could also look at our wheel and come up with the same thing, because we know we have 1 in 6 as a winner. All right. So let's say that this one right here is a winner. All right. One winner for every 6. So 1, 2, 3, 4, 5, 6. All right. So in other words, I have one winner for every 6 losers, for every 5 losers, for a total of 6. All right. If I keep going, one winner, okay, then 1, 2, 3, 4, 5 losers. Okay. One winner, 1, 2, 3, 4, 5 losers. Okay. So how many total winners did I have? All right. 1, 2, 3. We get the same answer this way. All right. Lastly, it says the probability of winning a prize is 1/6. If I spin 30 times, how many prizes should you win? And again, what I'm going to want to do is I'm going to multiply these together. All right. This is my probability of winning. This is my total. Okay. So if I multiply these together, that's going to tell me how many winners I should have. So again, 1/6 times 30, or 30 over 1. So give me 30 over 6, which is 5. Okay? All right. Now again, where does this come from? We could kind of use our rule, but remember our equation, the probability of something happening, all right, was our outcomes, or our favorable outcomes, divided by our total. All right? Okay, well, what do I know, right? I know my probability is 1/6. Okay? I know the number of outcomes, right? Well, I'm trying to figure out how many, so I don't know. And then how many total rolls am I doing? 30. Okay? And this is where we can set up a proportion. And you've seen these a little bit, and we're going to go more into depth in these later, but how we would solve this, we would take 30 times 1 and divide it by 6, which is exactly the same way as we set that up here.